Hello students. Now we come to the topic effect of nuclear mass on atomic spectra. Earlier we were considering only the motion of electron around the nucleus. In this case we have calculated energy that was equal to minus mz square e raised to power 4 8 epsilon naught square s square into 1 by n square. Converting this equation or writing this equation in the form of lambda, inverse of lambda, or in the form of wave number, that was equal to minus r 1 by n1 square minus 1 by n2 square, where n1 and n2 is the principal quantum number and r is the Rydberg constant. The value of it is given by r is equal to mz square raised to power 4 8 epsilon naught square h cube multiplied by c. Now when the electron make transition from a higher level to lower level, then there will be emission of spectral lines forming atomic spectra. Now if we consider the motion of nucleus as well, and like if we consider transition of an electron from higher level to lower level, then there is an emission of photon. So corresponding to various transition, there are emission of various photon having different frequency or wavelength, forming this atomic spectra. Now if we consider the revolution of nucleus and electron inside this atom around a common center, that is the center of mass, that will be the center of mass around which both the nucleus and the electrons are revolving. Now so for the mathematical calculation, now we have a nucleus here and electron here. Electron and nucleus are separated by some distance, that is denoted by r, and here it is the center of mass, and this distance we consider x, and the remaining will be r minus x. For the equilibrium condition, now mass of the nucleus is assumed as capital M and electron is small m. So for the equilibrium condition, we can write m into x, that is this distance of this nucleus from this center of mass, is equal to small m r minus x. So solving this equation, mx is equal to mr minus mx, m plus m into x is equal to mr. So x will be mr, m plus small m. So r minus x will be equal to r minus mr divided by m plus m, r m plus r m minus mr, m plus m. This quantity will be cancelled out, so we will be left out with mr, m plus small m. So r minus x will be this one. So we have calculated the distance of electron and nucleus from the center of mass. This is the x and this is the r minus x. Now as both the revolution is inside the nucleus, so the total angular momentum of the atom as electron and nucleus is inside the atom. So the total in the atom, there is a nucleus. Around this there are revolving electrons. So the total angular momentum of the atom will be equal to the sum of angular momentum of electron plus angular momentum of nucleus. And we know angular momentum is written as L is equal to mvr if r is the perpendicular distance. Now in this case, if we see here, if we see here, then perpendicular distance is x. This is the perpendicular distance of nucleus from the center of mass, that is angular momentum of nucleus will be L is equal to we will write this equation as we know V is equal to R omega. So this form can be written as m V by putting the value of V R omega R is equal to m R square omega. This form is when the perpendicular distance is r of the particle, rotating particle. Now in this case, the particle here is the nucleus that is revolving around center of mass. So angular momentum of nucleus will be L is equal to mass of the nucleus, and the distance of nucleus from the center of mass is x. So here x square, here r is replaced by distance x, and omega is the angular velocity. Similarly, for the electron, Le is equal to mass of electron, and the distance of electron from the center of mass is r minus x. By putting here the value of distance r minus x in omega, so the total angular momentum will be m x square omega plus m r minus x square omega. So m, by putting value of x, that is mr divided by m plus this omega, plus by putting the value of r minus x, that is capital M r m plus m into omega. On solving this equation, we will get m square r square plus this plus m square r square m plus this whole square into omega.